Hello and Assalamu alaikum. I am MD Sirajul Munir. My supervisor is Dr. Syed Hamid Hussain Madni. My research title is a blockchain a remedy for IoT privacy and security issues. The table of content is this. Nothing to say here. I move forward to the next slide of my introduction. So let's come to the introduction. My work depends on IoT. So IoT is a network of physical devices. It includes like sensors, devices, automation. It makes automation, convenience, and efficiency better. But the increase in connectivity also raises security and privacy concerns. Device spoofing, and fake authentication are two common risks that came up with because of the increase of connectivity. Due to the complexity of IoT design, traditional privacy and security measures are no longer enough. That makes it easier for hackers to find holes in the system and take advantage of them. So my proposal is blockchain technology to be a remedy for this, which started out as the cryptography behind Bitcoin could be an answer. It saves, verifies, and stores data or transaction without any kind of help of third party. Cryptography is used by blockchain to protect information and make sure that only authorized users can get it. IoT's reliance on central server concept is the main problem here to be solved by blockchain ledger. So as we all know, blockchain is a distributed ledger. So IoT can be more safer and more private at the same time by using blockchain technology. So this is my introduction part. Let's go to problem statement. In my problem statement, ensuring secure and reliable data transaction remains a challenging task in IoT. Traditional centralized server models introduce vulnerability points, leading to risks such as device spoofing, false authentication, and data leakage. Existing security protocols like ECC, ECDSA are computationally heavy and heading overhead cost in processing and energy consumption, which limits their feasibility for low resources IoT devices. Additionally, current implementation of blockchain technology through promising in terms of security are still have some issues with scalability, energy efficiency, and latency problems. With the increasing scale and complexity of IoT networks, a lightweight, secure, and scalable solution is critically needed. Our research aims to these problems by developing an innovative idea of solving the problem by blockchain technology. With this is optimized blockchain technology to enhance the privacy and security of IoT while minimizing the computation and the overhead, as known as overhead. So these are the three components of IoT: things with network sensors, known as TNSA, RAW, and ACE. So we can see here three components. The issues here when data transfer from here to here, like RAW to ACE and ACE and ACE to TNSA. Things can happen like the hackers can hack the network and came into the network and use this data for their further use. So this is the problem statement, and also this inside the components while data are processed, that is another time when the thing can happen, the hacking. This is known as false authentication, data spoofing, device spoofing, etc. So the figure 1.1 I already showed I already tell that interaction between components during this process in IoT, losing and mishandling data can occur because the data flow process is not 100% accurate. Data must flow in certain protocols in order to go through the internet, and there is a strong likelihood that external factors such as hackers could hack or misuse the protocols. External users can hack or take control of the computing engines during the second interaction between RPIDS and ACE. The third interaction is between ACE and TNSA, where feedback based on the computing algorithm must be sent and things accordingly. This is the possibility of taking over the negative control over feedback loop. Not only at the same time of the individual component has the chance of losing data, also the individual component has the chance of losing data, which occurs by the protocols. So my research objectives are 4 objectives: to identify the issues with security and privacy, and then the investigate of security and privacy issues and risk associated with this central server concept, and to propose the blockchain technologies, distributed ledger technology to improve the privacy and security of IoT's devices, like to solve the problem of device spoofing, false authentication, and data leakage. To evaluate blockchain technology for IoT and privacy and security. This is now my fourth objective. So these are my findings from the literature review. Security and privacy issues, innovative algorithms and frameworks, problems and with performance compatibility and scalability. So there are a lot of a few problems I have found, like privacy and security issues. That is, the research we looked at, it shows that IoT systems have a number of security problems, such as this I already mentioned: device spoofing, false authentication, and data leakage. Several studies have suggested blockchain-based solution to this problem, which an emphasis on a strong decentralized protocol, secure and encrypted data storage. These innovative algorithms and frameworks. The studies looks at use a wide range of new algorithms and frameworks, such as cryptographic algorithms, access control systems, and systems on epileptic cryptography. And problems with the performance, compatibility, and scalability, many suggested, and how well they work, how they work with the existing systems, and how they can interact with the existing system. So the research gap is this: the recent research has come up with a number of ideas for now to deal with these problems, but none of them deal with the security and privacy issues in a complete and decentralized way. Also, most of the solutions that are already out there don't take into account the unique features and limitations of IoT systems, such as limited resources and problems with access. Blockchain technology, which is known for being decentralized and honest, has been seen as a potential way to improve the security of IoT devices. But currently, using blockchain technology to solve privacy and security problems in IoT is still in its early stage and hasn't been looked into so much. There has lot of serious study on how blockchain technology works in systems, especially to stop device spoofing, false authentication, and data leakage. So this lack of a study shows how blockchain technology can be used for the existing IoT system, and this study aims to fill up these gaps by proposing and evaluating blockchain technology for IoT privacy and security issues. So these are my methodology for identification phase, investigation phase, and development of proposal phase, and evaluation on performance phase. So I go to the next. This is my proposed distributed blockchain technology. This system is a hierarchical framework built on blockchain that is meant to improve IoT security in a smart home. It is made up of network of high resource devices on nodes that are grouped into the clusters and led by cluster heads. In each cluster, the unique public key is given to each CH, which is cluster head, which helps to keep deal with the blockchain safe. A two-tiered ledger system for both local and network-wide activities is also a part of the framework. This system uses a method called distributed trust to figure out how trusted these cluster heads are, which affects how often transactions are checked. Lastly, user data is stored in the cloud with unique ID, and each unique ID has a public PK, which is a public key. This is how the framework actually works, and this is how it will be safe and built on blockchain's distributed ledger system. So the proposed solution is we introduce a unique solution aimed at addressing in the inherent security, privacy, and scalability issues with IoT networks. The proposal based on a hierarchical blockchain structure which has been specially designed for IoT applications, aiming to eliminate the limitations of centralized models. In the proposed architecture, lower and IoT devices rely on immutable ledger IL for transactions, significantly minimizing the computational overhead and power consumption. For higher end devices, a distributed public blockchain is deployed, ensuring robust trust and security. Furthermore, our solution features a trust mechanism that acts as an added layer for security monitoring and node behavior, and reducing the likelihood chances of activities. In summary, our proposed methodology bridges up the strengths of blockchain technology with the functionality of IoT, offering IoT network that is significantly safe, private, and scalable. So this is my dataset description. I will use a synthetic dataset which is using by NS3 simulator. A simulated dataset is made to test how the suggested blockchain-based security framework for IoT system works. This made-up dataset is a key part of the study because it shows how a typical IoT network will work. So our artificial network is made of 50 nodes. 13 of them are cluster heads. The jobs, interaction, and behavior of these nodes are set up to match the complexity of the variety of real-world IoT network. This makes our synthetic dataset realistic and useful for our study. IoT activities are used on transaction, which how we can each node how each node talks with the others in a simulation that lasts for 60 seconds, and 960 transactions will be made, and which are the main data points in our data set. These events, along with information on traffic flow and processing overhead, are the most important parts of our dataset. This lets us look into device spoofing, false authentication, and possible data leaks in IoT system. Our reported dataset is the average result of 10 separate modeling us to make sure it will show the best result. So this is my flowchart for the proposed blockchain technology. Here is the start. I will initialize the network. For each transaction, verify transaction, create blocks with transaction, add to blockchain, and activate the mechanism if threshold reached. This loop will continually go up with the data when data enters. For each stage, there will be another loop to broadcast the latest block. A new block comes, and it will broadcast as the new block, so the finalize operation, and then this is just a simple overview of my proposed flowchart. So it needs more explanation, and this is my proposed pseudocode. Okay, so the initial result look like the proposed novel and effective solution address the privacy and security challenges in IoT system. Leveraging blockchain technology, we eliminated the need of central server, reducing the risks of device spoofing, false authentication, and data leakage. Additionally, we designed a hierarchical structure employing an immutable ledger at the lower end devices and decentralized public blockchain at higher end devices. Our simulated environment demonstrated improved security, reduced the overhead, paving the way of more secure and efficient IoT ecosystem. You can see in the result, by our method, the overhead is reduced by 50%. So the main question is how reducing overhead can improve IoT and privacy security. So with reduced overhead, the network becomes more efficient in handling and storing data. The efficiency minimizes the chances of errors, delays that can lead to vulnerabilities, thereby enhancing security. Faster response time, reliability, scalability. These things, lower overheads often result in quicker system response. Rapid response times are crucial for detecting and migrating any potential threats swiftly, further improving of the security of the network. So this is how reducing overhead can improve IoT privacy and security. And thank you. This is the presentation. Thank you. This is the end of my presentation.